Hey guys, I just wanted to record myself doing another lesson on displacement and how to calculate it. So I've come up with a few examples that I want to go through. This might help you on the quiz and the test, so make sure you review this if you've already taken the quiz and test and missed a lot of these questions. Please watch this and take notes on it because it can help you on the final exam as well. So first of all, before I get into the example problems, I want to go over the definition for displacement. Displacement is basically a vector straight line length from a starting point to an ending point. And remember that the displacement formula could be the change of x equals x minus x naught. And let's talk about these variables for a second. The change of x, or the triangle x, stands for the change of distance, or the change of how that object's going to move. X can be represented as the final x position or the final object position, and x naught, which is the x with the little sub o, is the starting or the initial x position. Alright, so here is the example that I'm going to walk through, and then we're going to look at three different specific examples of these numbers. So it says an object will go through the following points. What is the displacement for the following question? So we have point A at 0, point B at 15 meters, point C at negative 25, point D at 5 meters, point E at negative 15 meters, and point F at negative 5 meters, and then we have finally point G, which is 10 meters. Alright, so I illustrated this by using different arrows, and I know it kind of went up because I just thought it would be clearer than doing them right on the top of each other. But basically these vectors are representing an object moving in those directions. So I have an animation of the car going from A to B, B to C, C to D, D to E, E, F, and then F to G finally. So that's basically what this question is asking. So let's look at the specific example 1, which is going to ask what is the car's position from point C to G. So basically we're going to be focusing on these bottom points here that is in the list. So point C, point D, point E, point F, and point G. So again, to illustrate it, if we start at the beginning of point C, which is going to be negative 25 meters, go to point D, which is at 5 meters, go back left at negative 15 meters for point E, then go up to negative 5 meters, which is point F, and then finally 10 meters to point G. So again, the car representing the movement would go to C to D, E, F, then G. So the question is asking what is the displacement or the car's position from point C to G. Alright, so here is the work that we can do here. So remember the formula again that we talked about at the beginning of this lesson, which is the change of the position equals x minus x naught. Remember, x is the final minus x naught, which is the initial or the starting point. So from C to D, you're going to take 5, and if you look down here, minus negative 25. So the starting point, which is x naught, is negative 25. So that's where you plug it in there. 5, which is D, which is going to be the final at the end of this segment, is 5. So 5 minus negative 25 is just going to give you 30 meters. So pause here and I want you to see if you can double check to make sure you've done this correctly. So go back down to your number line and count from C to D. 5, 10, 15, 20, 25, 30. And you're moving in the right direction, so it should be positive for this example. So again, positive 30, that checks out. From D to E. So we're going to move from D to E, so we're focusing on this yellow arrow here. The final is going to be negative 15. The initial is positive 5. So you set it up in the displacement formula. Negative 15 minus 5 equals negative 20. Let's check. If you follow and count what that yellow arrow is down below on the number line, it would be 5, 10, 15, 20. We're moving to the left, so that should give you that negative 20. The next point, from E to F. So we have E, which is going to be at negative 15, which is the starting point, or the x naught, minus, and then you have the F, which is the final, which is negative 5. So to set that up with the displacement formula, would be negative 5 minus negative 15. And that's going to give us a positive 10 meters. So let's make sure we have done that correctly. 5, 10 on the number line. So from E to F, we're going to move in the right direction, or the positive direction, 10 meters, and that checks out. So we've done that correctly. Then we can go to F to G. So F is at negative 5, G is at positive 10. So if we plug those two numbers in from the final minus the initial, the final is 10 minus the initial, which is negative 5. So 10 minus negative 5 equals positive 15 meters. Alright, so now since we found each individual vector, we're going to add the sum of those vectors. So we're going to have 30 plus negative 20 plus 10 plus 15, and that's going to give us a positive positive 35.0 in the right direction, or the positive direction. So if you want to take a step back and just think about this for a second. So if the question is asking what is the displacement from C to G, and you've drawn a number line like the one that I did here, don't worry about D, E, and F, but think about C to G. If we move 5, 10, 15, 20, 25, 30, 35 in the right direction, or the positive direction, it's going to give me G. So that checks out, so we know that this is the correct answer. Here's example 2. So now we're going to be looking at the same points on the same number line, but only looking from the start of point B to the point D. So displacement is going to be from B to D. So again, here's the animation of the car moving from B to C, and then C to D. Alright, so the work, we've used the same formula from B to C. This final is negative 25. The initial is positive 15. So we do negative 5 minus 15.0 equals negative 40 meters. Same thing from C to D. We have the final, the initial, which is negative 25 minus the final 5. So it's going to be 5.0 minus negative 25.0, which is going to give us 30. And then we're going to add the two vector sums to get the final displacement. So negative 40 plus 30 is going to give you a negative 10 meters, or left. So again, take a step back. If you're going from B to D, and if you've drawn that number line, look where B is and look where D is. If we go 5, 10, then we're moving to the left. So again, negative 10 meters left is going to check out. The last example, which is going to be from point C to F. So again, let's visualize it on the number line. So you're going to have C going to D, D going to E, E going to G, and E going to F. So there's the car simulation. So again, from the formula, change of x equals the final position minus the initial position. So from C to D, the initial position is negative 25, the final is 5, so to set it up into that formula will be 5 minus negative 25, which is going to give you 30 meters. From D to E, the initial is negative 5, the final is negative 15, so if we plug it in, the final is negative 15 minus 5, and that's going to give us the negative 20 here. And then from E to F, we're going from the negative 15 to the negative 5. So set that up in the initial, or final minus the initial. So it's negative 5.0 minus negative 15, which is going to give us a positive 10 meters. So again, we find the sum of the three vectors, 30 plus negative 20 plus 10 equals 20 meters in the right direction. So look back at your number line. If the question's asking at the start of point C to the end of point F, here's C, here's the end of F. We're going to move 5, 10, 15, 20 meters, and we're moving in the right direction, so it's positive, so everything checks out. So those are the 3 examples that I wanted you just to kind of review and make sure you understand. If you haven't taken the quiz or test, if you've already taken the quiz or test, make sure you review and look at that feedback to make sure you know exactly what you did wrong. Thanks for watching.